Hello and good morning, CTS267 Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this morning's video tutorial is going to be a tutorial and solution set on challenge activity number 9, where we're still going to be focused on the PILE Forensic Accounting Limited network. So as you can see, this has not changed. The network layout hasn't changed since the last challenge activity, which is also the PILE Forensic Accounting Limited. So let's go ahead and dive in here with the scenario and take a look at what we're being requested to do. So let's see here. We're still Sechnik employees. A man called in and introduced himself as an employee of PILE Forensic Accounting Limited. He's reporting that he's unable to use Telnet to access the branch router via his PC, PC3. He's kindly asking for you to fix this issue. And then right after you hang up the phone, Carrie, the customer engineer at PILE Forensic Accounting, she calls in a panic. So these are, I want to say these are kind of related here, right? So we've got this individual who says he's an employee who calls in, and he's reporting that he can't Telnet to access the branch router via his PC, PC3. However, he's given no information. If he was supposed to be able to access the branch router, we would probably know who he is, right? So this is sort of a misdirection here, where actually this part right here. So this is really a misdirection where we have no idea who this individual is. He's some random guy that's calling and asking for access. So access should not be granted because we don't know who this individual is. And then now we get a call from Carrie, and here's where we have the legitimate troubleshooting, which is none of the company users have internet connectivity. And so we're going to use the address 209.165.201.129 to try to sort that out. So let's look at that as the first problem. So let's confirm that there is actually an issue. So if I were to say ping 209.165.200.129, and I believe that is, let me double check that. Let me double check that real quick to make sure that's the, whoops. Yeah, there we go. Okay, 209.165. Okay, so again, we don't have connectivity from PC1. What about PC2? Let's take a quick check here. Let's see if we can trace out there. 209.165.200.129. Oh, forgot the numeric, but we'll let that run, and we'll come to PC3. And we'll do the same thing. We'll say trace over to 209.165.200.129 numeric. All right, so we make it up to the HQ1 router here, and that's probably where we should make it over here. While we're waiting for the resolution, let's quickly run the trace over here. 200.129. Oops, left the numeric off again. Let's rerun that with numeric, and there we go. And so we make it to basically the front door, right, to our enterprise front door, and you can see PC2 did the same thing. So where are we making it to? We're getting right here to the HQ router. So if we come on the HQ router and we go from user exec to privilege exec, and then we say show IP interface brief, we can see that that's the Ethernet 00 interface on that front door router. So in other words, we're making it into this router, but then we're not able to access anything on the way out. So let's take a look. We knew that we were running BGP before, right? So here's where a little bit of previous knowledge may come in handy. So let's say show IP BGP summary, and let's see. All right, well, it looks like we've got prefixes that are being received, and so the BGP peerings are clearly up. Show IP BGP, what's the BGP rib look like? Unfortunately, it's kind of a scrambled hot mess here. So, but we are clearly receiving routing information from the service providers. So if we've got information coming in from the service providers, can we ping that address from here? 209.165.200.129. So we can ping from the HQ router. Can we trace from the HQ router? So let's say trace to 209.165.200.129, and we should have dropped in the numeric in there. Let's say numeric. All right, and so we go to 200.5 for the first hop. So again, this is a very similar scenario, right? Remember, we're in the same network, so we are going out via ISP1, right? So let's test this. Let's see, does it work going out ISP2? What happens if we get into global config, interface Ethernet 01? And let's make sure this is the right interface. It should be 200.6. It is. And so let's go ahead and shut that interface down. So if we shut this interface down, what should happen is we should lose the BGP peering with ISP1, and we should be maintaining the BGP peering with ISP2, which would be, I believe, 201.6. So let's say do trace 209.165, 200.129, and let's just make sure, keep forgetting the numeric there, and let's just make sure that and let's say numeric. Yeah, and so we go out to 201.5, which is AS65222. So we do trace out to the other path, and it successfully works. So let's say no shut. We'll bring that interface back up. So when we talk about sort of splitting the problem in half, we've confirmed that in terms of connectivity, and let's bring out the drawing tool here, we've confirmed that in terms of connectivity, PCs 1, 2, and 3 can make it all the way up into the router. So we're successfully getting through that interface right there into the HQ router here. And then we've confirmed that the HQ router itself, right, proper, can get out to ISP1, and we've confirmed that it can get out to ISP2. So the issue, most likely, is something to do with HQ1. So now think about this. If we think about this logically, and we know that there are ACLs applied, there's infrastructure ACLs applied on these outbound interfaces, right, those internet-facing interfaces to the service provider, we can get through that interface without any problem. So there's a very good possibility that if we can make it to the router from these different networks, but we can't get out, but we are able to get out when we're, and again, it would be sourced, all the packets we're generating would be sourced from the IPs on those interfaces right there, that is it possible that one of those infrastructure ACLs, either in the inbound direction or in the outbound direction, are having some sort of effect? Or could it be that there's simply no information for those ISPs to route back to us? So let's go ahead and clear this out. So we're going to focus our attention on HQ1 here. And so the first thing we want to look at is, let's go ahead and take a look and see what that ACL looks like in terms of do show run interface Ethernet 01. And let's look at Ethernet 02. I think they both have the same ACL applied, that IP access group 100 in, and we're doing NAT, so that's not a big deal. So let's take a look at do show access list 100, and you can see we have quite a few additional entries here, and two of which we should be very, or I should say 4 of which we should be very, very familiar with. So here are our 2 BGP entries. And so in looking at these first 2 entries, a quick review here, if it's coming from 209.165 port number 179, sourcing from 179, who is the server with ISP, between ISP1 and the HQ1 router? So we would say that ISP1 would be the server. And then when we look here, actually that's the same line. So ISP1 appears to be the server side of this TCP communication, and then ISP2 on the other side, and that's why we have the matches here. But we know that those 4, I'll do them all here, we know that those 4 lines are for the BGP peering. Okay, so we've got this UDP host, permit any from 209.165.201. That would not be stopping us here coming back inbound. Neither would this one. And the ICMP. So the ICMP, it's interesting. So ICMP is being allowed back in. So the trace routes and the pings are not being blocked on the return path. And we know that we make it up into the router, but let's just double check here real quick and let's see if we have do show run interface, or actually do show IP interface brief. Was it Ethernet 00? Yeah, do show run interface Ethernet 00. And we've got an outbound ACL, so do show access list. Let's check this out, access list 101. Again, just using our previous knowledge, do show access list. And we have a 100 there. Oh, so there is no 101. So that is interesting, because I do not see an access list 101. I see access list 1, 10, this route out, and we're denying the 209.165.200.248. So there doesn't appear to be an access access list 101 that's applied to that interface. And that's interesting, because typically you don't put a statement in there for IP access group unless you have an access list. So this may be either part of the problem or a contributing factor. So let's do this. Let's pull this off for right now. We're going to say no IP access group 101, 101 out. And let's check real quickly here and let's see, does that change anything? And again, very quick to tell if it's going to help anything or if we're simply just looking in the wrong area here. Yeah, and so it does not appear that that's going to assist us at all. But again, there is no ACL 101, so we are going to leave that off. Okay, so we've taken a look at the access lists, and it doesn't seem that there's anything there that would be preventing our connectivity. So let's go ahead and take a look, do show run section BGP. Let's look and see what we have going on with BGP and make sure, redistribute internal. Okay, so we've got the network statement here for the 209.165.200.248. Okay, and then we've got some distribute lists. So let's take a look at that route out. Yeah, and this is interesting. So we're denying. Yeah, okay, so this has got to be one of the issues. So when we take a look at this, you can see here in the BGP configuration section, we have going toward the neighbor. Right now, these are the neighbor statements. So these are the peering statements that help us, or I shouldn't say that help us, that establish the BGP peerings between HQ1 and the two ISPs. And so here we've got this distribute list route out, and it's applied in the outbound direction. And the same distribute list is applied referencing the same access list for both neighbors. And when you look at what that route map, or I'm sorry, not route map, what that distribute list is actually referencing, it's saying deny 209.165.200.248, and we've got a wildcard mask of 000.7, which would be 255 for a subnet mask, would be 255.255.255.248, right? So we're not advertising, or I mean, we were supposed to be advertising that information because we have the network statement right here to advertise this network. However, with the distribute list, we're negating that advertisement. So let's take a look here, and the way to see this right? Because we want to make sure we know how to validate this, would be do show IP BGP neighbor, and we're going to do advertised routes here, 209.165.200.5, and when I type advertise, and actually to put this out, it would be advertise routes, but I just put the beginning of it. But you can see here that it shows that we're not advertising any prefixes, right? And so what we're basically doing is we're basically blocking our public IP space. And so let's do the other neighbor statement. So it's going to be 209.165.201.5, and you can see we're not advertising our public space. And so this would be enough for us not to be able, for us not to be able to have traffic route back to us. So again, we've got a distribute list that's referencing an ACL that we're applying to both neighbor statements in the outbound direction, and the ACL is specifically denying the advertisement of our public space. And this is a problem because when we look at the diagram here, sure, we can get to, from HQ, we can get to the ISP, and we can get to ISP2. However, if we're not advertising our 165.200.240.248 slash, and what are we advertising here? So another 240, so 20, where are we at? 128, 196, 224, 240, 248, 1, 2, 3, 4, 5, so 21. Is that right? I think that's correct. So we're not advertising our network segment out. It's not going to make it out here to the internet. And remember, it's out here in the internet that the address that we're trying to ping resides, this 209.165.200.129. So when that traffic tries to come back, it is not successfully able to come back. And I apologize, it's not 21. I went out to 16, 17, 18, 19, 20. Yeah, it is a 21. But we are 24, 25, 26, 27, 28, 29. Let's make sure that's correct. 248/29, because if it's 248, again, it's 128, 192, 224, 240, 248. So 24, 25, 26, 27, 28, 29. All right, we're good. /29. Sorry about that. I was looking at it backwards. So that's the network space that we have, right? We've got 6 usable IPs, and we're basically blocking that space from being advertised, which means it's never going to get picked up out here in the internet cloud. We're never going to have any traffic return back because the internet doesn't know how to get back to us. So let's go ahead and resolve this and jump on the HQ router. And so there's a couple things, there's a couple of ways we can do this. We could remove the distribute list in the outbound direction. That's one way because, the ACL simply has a single line, which is basically denying our public space, right? The advertisement of our public space. So we could just simply ditch the distribute list because it's no longer needed. The other thing that we could do is we could simply remove the deny statement and change it to a permit statement, right, to allow the advertisement of that space. And that may be something we want to do. But again, this isn't needed, so it's sort of a coin toss here as to how you want to approach this. We could pull the distribute list off. That's fine. Or we could fix it so that what we're allowing to go out is basically our public space. So, and that would probably be what you're doing, because you're trying to control the advertisement, the networks that you're advertising in the outbound direction. And as you can see, we're only advertising those public IPs. So let's go ahead and do that. So it's route out with a capital R. Let's make sure we get this right. So let's get out of here, and that's how we're going to solve this. So we're going to say IP access list, and is it standard? Yeah, standard route out. IP access list standard route out, and we're going to say no 10, and then we're going to say 10, and instead of deny, we're going to permit, and if you see what they're permitting here, we're basically permitting simply that network statement right there, the 209.165.200.248 with that wildcard mask. So we're going to say permit 209.165.200, let me make sure it wasn't 201. Yeah, 200.248. And then the wildcard mask 000.7. Okay. And we don't need to log it, right? So we've changed the ACL. So now when we say do show access list route out, so now we have a permit statement, right? So we're allowing things. But do we have connectivity yet? So let's check and see if we have connectivity. Or is there something else that we need to take into account? And remember, we're dealing with a distribute list applied to BGP. So there's a very good chance, and I'll let that run on PC1, there's a very good chance that we need to clear things here. So we're going to say do clear IP BGP star out and star in. So we're going to refresh things in a non-disruptive fashion, right? So we're not tearing the BGP peering down, and then take a look at what happened there. So let's rerun that trace, and there we go. And everything is working as it should, because now the internet, and if we were to come back to HQ1 and we were to say show IP BGP neighbor 209.165.200.5 advertised routes, now you can see that we are advertising the routing information required for that return trip back to us. So now the internet is getting that information, and you can see that both ways here, right? So that takes care of the connectivity out. If we were to quickly check PC2 and PC3, and let's take a look at PC2 here and just basically say ping 209.165.200.129. All right, we've got connectivity now, and PC3 should work without an issue as well. So ping. And there we go. All right, so that's been taken care of. Let's take a look at the second ticket. So Carrie also noticed that HQ1 is not synchronized to the NTP server that she has configured as preferred. And so that would be, hold on just one second here. All right, so let's go ahead and take a look here and see what we've got going on. Could be NTP authentication, possibly. Maybe the key is wrong. Maybe we've got the prefer statement on the wrong NTP server. So, but it looks like, again, we're supposed to be preferring, it looks like the 193 should be the primary, and then 225 and 129 should be the backup. So let's dive in and take a look here and see what we've got on, whoops, on HQ1. So lots of problems on HQ1 here. So let's say show run and include NTP. All right, so there are the servers. Those IPs all look good, and our prefer statement is where it's supposed to be. So let's say show NTP status, and the clock is synchronized. Aha, so the clock is synchronized, but as you can see, we're not synchronized to the preferred time source. So is it that maybe the preferred time source is having issues? 209.165.201.193? All right, so we can reach the preferred time source. Show NTP associations. Okay. So 193 shows that it is in the init state, and typically if it's stuck like this, either there's a misconfig of some kind, and let's say, so we don't have any authentication taking place here, and typically if you have mismatched authentication you can end up in the init state. Let's see if, all right, so 193 show run interface Ethernet 01. All right, so IP inspect out. So we've got an outbound And then we've got the inbound ACL as well. And did we see show run access list? Did we see, and that, show access list. I always type show run access list for some reason. So show access list, we saw UDP in here, and sure enough, yeah, okay. So we saw reference to NTP. So remember that NTP uses port 123, probably one of the easiest assignments to remember, and it uses UDP, right? NTP is not TCP based. So when we were looking at this ACL earlier, and we were talking about the BGP lines that we are very familiar with, we came upon these two lines here, and having looked at this and then seeing that two of those were the time servers. So what is the issue here, right? So we look good with 129 and 225. However, what is not being allowed inbound? Exactly. We don't have an entry here for the primary or the preferred NTP server. We do for 129 and we do for 225, but we're not allowing UDP to come into the enterprise from 193. So again, very simple fix here. So lots of ACL work over these last two or over the last two challenges. So let's get into where are we at here? Access list 100 IP, access list standard one, or is it standard? I can't remember if it's standard or not. Extended. It is extended. Access list extended 100. And here's what we're going to do, and this is one of the nice things, is we can just drop it right between 40 access control entry 40 and 50. We're going to say 45 permit UDP host, and this is our NTP host 165.201.193, and we will simply match the entries that we have here for the other two NTP sources. So if I was to check and see, do we have any matches coming in yet? We do not, right? But NTP is notoriously one of those protocols that definitely takes some time to sync up. And let's see here if we were to do show NTP status. My guess is it hasn't flipped over. Show NTP associations. All right, so we're still in a init. So is it possible that it was something else? And we can force this if we were to say clock, is it read? What is it? Read calendar. Read calendar. All right, so let's see what happens now. All right, so the clock has been updated. Let's do, aha, so now we have traffic coming through, right? So it shows that it's being matched. So now if I were to say show NTP associations, we have now resolved the init issue, right? Where we were running NTP locally, but we weren't receiving any traffic back. So now we are in the local status, and excuse me, now let's go with show NTP status, and it shows that we are synchronized, but not only are we synchronized, we are synchronized to the correct time source. All right, so those were the three issues that we had, right? The one non-issue, which was sort of a social engineering attack where someone calls in and says, hey, give me telnet access from PC3, and we have no idea who that individual is. We don't give them access. Then we took a look at the distribute list that was actually overriding the BGP network statement, where we were advertising our public space out to the internet. That way, traffic from the internet, not ISP1 and ISP2, but traffic beyond ISP1 and ISP2 would know how to get back to our public-facing IP addresses. And then finally, the NTP issue, where, again, we had an ACL that was missing, right? Or I should say an ACE, an access control entry, missing from the ACL that we needed to resolve. All right, well, that's going to wrap up challenge activity number 9. Enjoy the rest of your weekend, and remember, make sure you move your clocks forward 1 hour, and there is no class this week. I will see you guys in 2 weeks. Have a good one.